Hi, everyone, and welcome to our podcast. Today, I have the pleasure to have Chandranil, who is a fifth year student at ISM Dhanbad. Today, he is going to share about his report, and it's mostly about seismology. And for a while, we haven't talked about really seismology, which is the basics of geophysics. And from there, we'll talk about a little bit AI and then also the renewable energy. So, Chandranil, welcome.
Thank you so much, ma'am, for giving me the opportunity. It's a pleasure from my end.
No problem. So, do you want to talk about your research and share the report perhaps that you have prepared for the podcast?
Yes, ma'am, sure. Just a minute. Is it
Yeah,
visible, ma'am?
the screen is visible, but yeah.
Okay. From the very beginning, I would like to say that it's a surface wave tomography, which I underwent in this previous summer at IIT Bombay.
Mm-hmm.
Uh, my guide was Professor Satish Moria.
Mm-hmm.
Here's this the contents of it. I would like to straight come to the abstract.
Mm-hmm.
So here is basically we are presenting the high resolution 3D atmospheric model, the area being the central Himalayas and Tibetan plateau,
Mm-hmm.
um, using the surface wave tomography method from the dispersion of the fundamental modes of surface wave. We have
So, did you
taken it,
collect that data from IRS station?
yes, yes, ma'am, yes,
IRIS,
ma'am,
yeah.
yes,
Okay.
ma'am.
Mm-hmm.
So for 74 permanent stations, the data was taken into consideration, in which it was around 6,000 Rayleigh waves and almost about 2,000 love waves.
Mm-hmm.
And time period for which was close about from 5 seconds to 60 seconds. And the tomographic images that we got from those particular curves, I will coming to it later. So from that, the inversion of it was done to get the 3D velocity distribution. This is just the synopsis, the overall thing in a nutshell.
Mm-hmm.
Uh, Now, coming with the introduction, it's just about the brief of the area and all those things, which
Mm-hmm.
I am not going to say anything in very detail. The
Mm-hmm.
geology is something that I want to talk a bit about. It is mainly located in the central Himalayas near the borders of India and Bhutan, precisely the Tibetan plateau. So
Mm-hmm.
the main objective of taking this very particular region was of its complex geology, which obviously is a hotcake for all the time.
Mm-hmm.
Uh, so that is what it is, because of which the region has been taken.
Okay.
So the main things, the region is characterized with presence of young and active mountain ranges,
Uh-huh.
including the eastern part of the Himalayas,
Mm-hmm.
and this also includes the rocks, especially the sandstone, mudstone, shales, conglomerates, which any of us being a geophysicist will love to have it all the time, the
Mm-hmm.
things. So that's the thing, that as a result of this, the intense pressure and temperature conditions associated with mountain processes and the sedimentary rocks that is having out there undergoes mainly what is that is the metamorphism. So the geology is again there's mainly content with the older Paleozoic and Precambrian rocks.
Mm-hmm.
So this is what the overview of the geology is. Coming next to the location in a pictorial form,
Yeah.
this is what it was: the Tibetan plateau, the Indian ones, the South China block,
Mm-hmm.
and this was the portion that was taken, the stations from which.
Right. Okay.
So next, the theory was there.
Mm-hmm.
Uh, so I know it's a bit boring to go through the theory portions, but yeah, just short manner.
So
It's just
what
the
does the first equation talk about?
first equation, ma'am, is mainly talks about the 2D phase of Google velocity maps. That is
Mm-hmm.
the in the terms of the r, that is the
Mm-hmm.
position vectors, in
Yeah.
terms of the co-latitude and the longitude.
Uh-huh.
That is mainly taken over here. The frequency dependent travel time, that
Okay.
TRL.
Uh-huh.
That's R and L stands for the Rayleigh wave and the love waves,
Yeah.
for which the dispersion curves were taken and plotting was there, which I'm coming after that.
Mm-hmm.
So that was what it was taken, and the dispersion maps were taken for the nonlinear related to a seismic structure of the earth. So this is what the theory goes a bit. And nextly, the surface wave tomography, when set of observed travel times for defined paths to infer a group of phase velocity maps, that is the CR, which I just said the above, and the frequency. We're assuming that the observed one is just a summation of the two terms.
Mm.
That is the for the Rayleigh and as well as for the love one. And the era 2 is being taken into consideration over here.
Well, which one
And
is
next,
the error? Oh, okay, I see. Uh-huh.
okay, this epsilon one.
Yeah, right.
So nextly, ma'am, the inverse related to the velocities we're taking. That is the 2D reference map,
Mm-hmm.
travel time perturbation related to the prediction error. Not much will be understandable from this particular theory, but
Mm-hmm.
coming on to the work that have been done, that is a bit way explainable.
Mm-hmm. Yeah,
So
sure. Let's go.
these are the terms that are mainly going into the consideration.
Mm-hmm.
The calculation part is there. So these are all the mathematical equations and all those forms. Mainly coming to the main thing, that is the data.
Yeah.
Data taken from, as I've said earlier, from the IRIS Data Management Center,
Mm-hmm.
DMC,
Mm-hmm.
and the broadband networks mainly included XA and YL.
Mm-hmm.
These are two global and regional broadband seismic stations, in which there are more than 74 seismic stations, and three component waveforms were taken.
Mm-hmm.
So this very particular data was taken into, and thereafter we are using seismic analysis code SAC in Linux,
Yeah.
in which we are mainly doing the entire process and entire processing part.
Mm-hmm.
Starting with a bit of pre-processing part was there, which for a small amount of data was done manually, and for the greater part, that is the main data that I worked with, that was mainly done with the seismic scripting portion,
Mm-hmm.
because that amount of used data can be pre-processed manually. That's something that is not possible. So that is what it is done. That the pre-processing mainly includes that the instrument response, mean, trend, tapering, filtering. These are the things that mainly includes
Yeah.
in it. Here's the stations that were taken.
Uh-huh.
The inverted triangles. So I'd like to zoom it a bit. So these were the ones.
Okay. Yeah, it's all. Why are the stations at the red regions? Oh, okay, I see. No, it's okay. Yeah. There's also
Yeah.
stations in that. Oh, yeah. Ocean.
Okay.
Okay. Mm-hmm.
And this is a bit of geological distribution of it.
Mm. Okay. I see. Mm-hmm. Okay.
Next, ma'am, the seismic wave dispersion was there, in which the inversion was done at a later stage. Uh, Before that, I would like to do, yes, ma'am, this one. Uh, the 2MFT program was there.
Mm-hmm. So what does it do?
It mainly does the this very particular uh, color map that comes into the picture, where we
Mm-hmm.
do need to pick these ones. We do need to this pick up these particular points, where for the Rayleigh waves it should be less than 4 kilometer per second, and for the love waves it can extend way beyond the 4 kilometer per second time range.
Mm-hmm.
It's basically coming from the theoretical portion, where we do consider it as a graph. I do have a picture of it, I think. Just give me a second.
Mm-hmm.
Um, Somehow I'm
So
not
what
getting
do
it.
you
Okay, it's
mean by group velocity? Can you explain a little bit?
group velocity. The basic reason for taking group velocity is that we are considering the entire wave train of it, rather than
Okay.
considering. the individual waves in the individual
Yeah.
portions in the particular wave, that is the phase ones.
Yeah.
We're taking the group velocity so that the entire wave train can be taken into consideration.
Mm-hmm. Right. Okay.
So these very particular points were taken, and we need to make sure. And this thing was done completely manually,
Mm-hmm.
because there is not as such software or anything like that which can be used. So
Mm.
this was a whole time-consuming task, because taking those like, like near about 7,000, and like
Mm-hmm.
I mentioned earlier, so that amount of data that was taken. So this was something that was time-consuming, and the mode that we took was the n is equal to 0 1, because that is the something that is the fundamental one. So
Mm-hmm.
taking the reason for which taking n is equal to 0, that was what it is. And I think I haven't mentioned it. Yeah, actually the screen would have been made it more clear, but I think I have missed that.
No, it's okay. You
Anyways,
can go down. We can discuss about the curve. We can talk about the curve.
yes, ma'am.
What do you see here? Yeah.
This curve was mainly, ma'am, for the Rayleigh one,
Uh-huh.
and this curve was for the Love one.
Okay.
So this is the
So
just a
can
brief
you just
description.
remind us what is the difference between Raleigh and love? So just
Yes, ma'am.
okay, yeah, the Raleigh and love. Yes. Can
Yes,
you
ma'am.
explain that,
So
please?
just Rayleigh waves are just formed from the longitudinal and transverse vibrations,
Hmm.
and whereas the love waves is just a horizontal share of motion in the action, or that is shared or transverse to the direction of propagation.
Mm-hmm.
So that is mainly the difference, and that very particular theory is written over here, that
Hmm.
both the waves travel and various depths under distinct wavelengths. Longer wavelengths disperse the same wave energy over a wider area and to greater depths.
Mm-hmm.
And the dispersion characteristic of surface waves is provided by the energy spreading to various depth ranges depending on the wavelength. In Rayleigh, the coupling between these two waves, that is SB, share that is the vertical component, and the longitudinal wave, that is the P wave, has spheroidal nodes, while the love waves has only toroidal nodes.
Okay.
From the diagram, I think it will be a bit
Mm-hmm.
clear what is written above. So this is the diagram. As you said, why group velocity? So that was something that is written over here, that why group velocity we are taking into consideration instead of the phase one. So taking the entire wave train, that was mainly the reason why the group velocity was taken,
Hmm.
and that very thing is written over here in a theory form. Next, the anisotropy, which was like the various the subsurface
Mm-hmm.
anisotropy that exists out there in that area. So it is present at all scales, not a second order effect from microscopic scale up to macroscopic scale.
Hmm.
The seismic anisotropy mainly manifests itself in the seismic wave field a number of ways, and there are several analytical techniques that we can detect and characterize it. Anisotropy in earth crust and upper mantle can be measured using receiver function analysis or surface wave tomography, where I haven't used the receiver function, I have used the surface wave tomography out here.
Hmm.
So the seismic anisotropy can be mapped in defined depth ranges and imaging of the geological objects such as the lithosphere and astrosphere boundary.
Hmm.
Followed by that, ma'am, the regionalization was there, which that the phase or group velocity maps are frequently inverted using uh, SWT, that is seismic
Hmm.
tomography, which is mainly based on the continuous regionalization of model parameters that are taken.
Hmm.
Due to that spatial uneven distribution of stations and seismic occurrences, an avoidable issue arises,
Hmm.
whereby the distribution of ray paths is far from homogeneous because of the inhomogeneity that is out there, and we are mainly assuming that the individual layers that we are taking are homogeneous for the sake of our calculation.
Okay.
But in reality, those things
But
are
it's not
actually,
right. It has an anisotropy and all that. Okay.
yes, ma'am,
Yeah.
that
Mm-hmm.
and that it's inhomogeneous.
Mm-hmm.
But for the sake of our calculation, we're assuming that the individual layers, very thin layers, we are breaking it into those very particular layers are homogeneous,
Hmm.
and they frequently having an impact on the tomographic model spatial resolution.
Yeah.
So we offer a more effective tomographic technique, which is based on continuous visualization, so that the discontinuity or the breakup that is out there because of the consideration of the layers, that very thing is minimized or
Hmm.
done in the most possible manner that it can be done.
Yeah.
And there's a special variable smoothing scheme. The next step, right, ma'am, is in defining the shear wave velocity model from the dispersion curves that I showed earlier. That was done using this regeneration method. Is a two-wave surface wave tomographic method. That is the
Mm-hmm.
regeneration, which is in this part. It mainly makes it possible, ma'am, to generate distributions and lateral changes of surface wave groups or phase velocities that are indicative of the shear wave velocity structure.
Hmm.
We are mainly considering the shallow structure zone where
Hmm.
the the surface waves are mainly confined into. So we are not going greater depth in it. The mainly the shallower portion of the surface uh, close to it, that are something that we are working here with. Here are a bit the other techniques that have been applied earlier. So
Okay.
it's just a
So
two-stage
maybe
inversion.
can we maybe let's go to the results little bit maybe
Okay,
then. Yeah.
okay, ma'am. So, ma'am, here are the basically the results.
Okay. Yeah.
So,
So let's do the can you increase? Yeah. So what do you see here?
ma'am, we are mainly seeing the number of paths, the
Mm-hmm.
time, and the average love waves, and down there it will be the Rayleigh wave. I would like
Okay.
to, ma'am, mention the outcome of it. These are the of the love ones for
Mm-hmm.
different paths and different time periods. So, I'm taking for 12 different periods of it. Uh, these are the 12 different ones.
Mm-hmm. 12 different time periods. So what is the
Yes, ma'am.
difference? What do you see in the difference like as
Ma'am,
a
basically the difference in the color lab of the color portion of it, that is something
yeah.
that is making out the
Can
difference in
can
it.
you show can you just explain between two different periods maybe? Just
Yes, ma'am.
picking two and just explaining what we see as structurally or something like that.
Yes, ma'am. Uh, so I think, ma'am, this way too will work. So yeah, ma'am. As you can see that this very particular portion where it is marked a bit more orangish, and here it is not very particularly apparent from it. This
Hmm.
very particular thing is appearing because of the time period and the number of paths, which is obviously lower in this case. And the number of paths, I mean the number of intersections that are taking place in this region. So the resolution and clarity of this very geological area is more apparent from it.
Hmm.
That is particularly brought about by the time period and the number of paths.
Right.
So the whole
Okay.
reason why we are increasing it is because to give about this particular resolution in this area,
Hmm.
because this is something that is on the lower side of it.
Hmm.
From the color map it can be seen that this on bit on the lower side. So this is something that the increase in number of paths and the time period it is taking about. Here is, ma'am, is written in a detailed way. So these were the 12 different periods that I have taken to
Mm-hmm.
measure the spatial variation. And it has been observed the lava wave group velocity varies from near about 7, -7 to 9 kilometer per second
Hmm.
related to. And for the Rayleigh one, it nearly varied from the
Hmm.
18 kilometer per second to 20 kilometer per second.
Mm-hmm.
This very particular variation indicates that for the Rayleigh one, it is way more higher in the range considered
Uh-huh.
in comparison to the love one.
Okay.
And this was the reason why, in case of the love waves, the number of uh, points or the number of stations that were taken was a bit less. Because for
Hmm.
the love waves, when those dispersion curves were plotted, those were not very particularly clear from it to pick it out. Whereas for the
Mm-hmm.
Rayleigh ones, it was way more apparent and way more clear, so that those
The
particular
rallies. Okay. Mm-hmm. I see.
right to clear it.
Okay. Okay.
So the lateral variation of group velocity represents the defined geological and tectonic features.
Mm-hmm.
A shorter period of the Rayleigh wave velocity map is more sensitive to Vs, as we can all know in the upper crust, where there is a longer wave period, has greater depth sensitivity according to its wavelength.
Mm-hmm.
For
I
the group love wave velocity map at less than 22-second period represents the upper crust between the 25 and 35 seconds, and are mainly influenced by the lower crust and up to 60 seconds representing the upper mantle. In the figure 9, I have mentioned this very particular the whole of it as figure 9
yeah.
at periods less than 12 seconds.
Mm-hmm.
The entire eastern Nepal Himalayas, the part of the southern Tibet, that is the main boundary thrust, and CMT shows high velocity relatively, and the Indo-Burman ranges show low velocity due to thick layer of the sediments. So
Okay.
by those particular deepening of this color, that is the increase in the time period, the thing that is coming out is the low velocity due to thick layer of sediments.
Mm.
So that
I
indicates
see.
that the region in the subsurface that has got a thick layer of sediments under it.
I see. Okay.
Next, ma'am, for the 12 to 28 seconds time period,
Mm-hmm.
12 to 28, yes, ma'am, this section, these four. For these four portions, uh, the values are way relatively high. For the eastern Nepal Himalayas,
Mm.
the parts of the southern Tibet and Sichuan fault, with increasing in the period from 18 to 48 seconds. And the group velocity values, as can be seen from the diagrams, also increases within this zone with increasing period. The low group velocity values, that is the red color, that indicates the presence of sedimentary rocks from
Mm.
time period 36 to 60 seconds.
Okay.
Actually, if it would have been side by side, I would think it would have been a bit clear. 36 to 60 seconds. So these six are then taking.
Mm-hmm.
I mean, I have interpreted these things in the lower this section.
So, Chandranil, we have 10 more minutes left. Maybe
Okay,
we
ma'am.
can kind of wrap it up and kind of if you can just give a gist of it, and then we can move into our second part of the podcast. That's more on talking a little bit about new technologies.
Sure, ma'am. Before that, ma'am, this is last the same thing for the Rayleigh one.
Yeah,
The periods and all everything are same, and these were the uh, tomographic maps that have been.
yeah, the tomographic map. Can you explain a little bit about the tomographic map? Maybe just pick one.
Yes, ma'am. Mainly, ma'am, the sediment thickness of the underlying subsurface. That is something that is brought into this picture with the tomographic maps,
Hmm.
with the number of paths that are mainly cross intersecting in that very particular area, and inversion of these very particular tomographic maps yields the velocity distribution curve.
Hmm.
So from these things, the interpretation of the subsurface layers can be done, and that is something that I have tried to bring about in this
Mm-hmm.
section of it.
Yeah.
Actually, ma'am, inferences or the conclusions are written in this very particular section of the report.
So,
That what
what
is
is
particular.
can you just tell it in your language, like what is the conclusion?
Mainly, the conclusion was with increasing number of ray paths and the time period, the as the number of ray paths intersected in a much more and, and concentrated in particular portion in a greater way. So that very particular area with the increasing number of uh, this color indication indicates that the subsurface is having way more thickness in the layer sediments.
Mm,
So that is, ma'am, I try to bring about that what is the subsurface geology in it from the Rayleigh and the Love waves dispersion curves. So picking those curves and plotting it on the maps, this was the inference that was brought about in it.
mm,
Mainly
yeah.
the subsurface nature of it, that how the layer is changing and how the thickness of the sediments of that particular geological area is changing.
Mm,
That is mainly that I was brought about in it.
great. So maybe then for the remaining few minutes, let's discuss what about. So do you think that these can be also done with deep learning or like the tomographic analysis? Are there?
Yes, ma'am. Yes. Surely, it can be done with the AI algorithms. Well-defined codes are out there, so
Mm-hmm.
using that very thing, it is definitely possible to form a synthetic model of it. This very thing
Yeah,
that I have done with the help of Linux, this it can be similarly done with the help of any uh, programming language, like Python or anything like that.
yeah,
Uh, it is absolutely possible, ma'am, to bring out a forward model where the synthetic data can be generated, and from that inversion can also be performed, which can also bring out the geological these types of geological models of that area as well. So both,
mm,
ma'am, forward modeling and inverse modeling can be done in it, and that is mainly can be done with the
yeah,
algorithm and the machine learning portion. So
got it.
yes, ma'am, there is definitely
There's
scope of doing this.
definitely a scope to yeah
Yeah,
improve this and all. So maybe the last part of the section, Chandranil. Um, what do you what's your because you're a geophysicist, what's your opinion on clean energy? Like of course you might be also reading some maybe courses or something. What's going on in the right now?
ma'am,
What's your opinion?
that is something which the future is all about, I guess, or
Mm-hmm.
not I guess. That is definitely the future that is going to be, because as we all know, the on a global scale, on a national scale, everywhere there has been a target that has been set that within this very year for India is 2050, if I'm not wrong. We need to switch it to the clean energies and everything that is
Yeah.
related to the oil and gas sector. So yes, ma'am, the research and the R&D and D and everything are going in that very particular direction,
Mm,
and obviously, ma'am, that's the future that we all are looking up to.
yeah, for sure.
So that's all the future is all about.
Yeah, yeah, for of course. And are you going to publish this result sometime? That's
Yeah, yes, ma'am. In this coming winter, I do have an extension of this work in it. So
yeah,
depending upon how that goes, so it's
yeah.
upon my guide as well, how he sees it. So yes, ma'am,
You
there is
can
a scope of
you'll
it of getting
extend this.
published.
Great, great. Yeah, we're looking forward to the publication. Thanks,
Sure,
Chantanil, for presenting this report. Very helpful, and of course, it's like basic seismology, and it's really, really nice to like brush up and also for our audience to look at the basic seismology. Uh,
sure, ma'am. Sure.
thank you,
Thank you
and
so
hope
much, ma'am.
our
It's
audience
all.
like this, like this.
I do hope they will love it as well.
Yeah,
Thanks
sure,
for the opportunity once again, ma'am.
no problem.